Today we're going to talk about Chapter 2, Standardized Recipes Are Critical. First, we're going to get into some of the aspects of what makes up a standardized recipe. The learning objectives for this chapter are: explain the importance of standardized recipes, list the procedures for developing standardized recipes, describe how to standardize recipes for a specific operation, calculate recipe ingredient cost, standardized recipe cost, and menu or plate costs. Explain how to ensure food safety requirements are addressed in standardized recipes, and explain procedures helpful when implementing and consistently using standardized recipes. And then finally, describe how technology impacts the use of standardized recipes. So first off, we need to identify what is the importance of a standardized recipe. Well, first let's decide what is the benefits of it. If you recall from chapter 1 that a standardized recipe is a set of instructions for producing a food or a beverage item, when followed, they are better to assure that the product's quality and quantity standards are met. One of the biggest benefits of this is going to be consistency. Consistency is the key benefit when it comes to a standardized recipe. Let's take, for instance, McDonald's. If you go to a McDonald's in, say, Fairbanks, Alaska, you're going to get the same Big Mac as if you go to one in Memphis, Tennessee. That's because they use a standardized recipe. It gives a sense of consistency across the board. But even within your local restaurant, maybe your favorite restaurant is, I don't know, we'll call Ruby Tuesdays. You like to go to Ruby Tuesdays, and you get the same thing every single time. You are a repurchase intent customer. That recipe, if it's not right, the next time you go in, then you're less likely to buy it. So that's going to be one of the biggest benefits for us, is going to be that consistency across the board. And because of that, we have to have things like ingredient details. We have to have the correct weights and measures for the ingredients. We have to have equipment and tools needed listed on there. The volume of the recipe to be produced, we call that particularly, will depend on the portion size. The time required to prepare the items, both in prep and cooking, storage and preparation information, and cooking methods to be used. These include things like blanching, sauteing, deep frying, and other methods. It also helps us control labor costs because we know how long it's going to take to produce this particular recipe. That comes a little bit later when we talk about costing, and it becomes a little more of a tricky situation. Surprisingly, standardized recipes are not used in some properties. Some of the reasons why may be that cooking professionals don't necessarily need them. Maybe they've been doing the same recipe for years. There's a problem with that. What if that individual leaves and someone comes on board? You may need that. There's not enough time to read a recipe. I don't buy that for a minute. Secret recipes will be stolen if they're written down. If you have any secret recipes, you probably need to check your organization. It sounds very Illuminati-ish. It's time consuming to keep them up to date. And then reading levels of some production staff are not adequate. Most recipes are written to be read by everybody. Accuracy in menu disclosures. This helps us assure that we are giving the proper information on the recipe, that if it says we are using Kobe beef, it should be Kobe beef on the standardized recipe. Developing standardized recipes. Standardized recipes are clearly important, so you need to spend a little time with them. So we're going to first start off by reviewing current menu items. Let's say, for instance, we walk into a new restaurant as a chef and we're asked to provide a more updated version of the menus, make sure that there's consistency across the board. So we want to review all the current menu items and then write standardized recipes for them. Now, really the very first step before we even get into the procedure is talk to your production staff. Talk to the employees, let them know what's going on, why you're doing this, and what the importance of it is. If you can get them on board, you're more than likely going to be able to have less pushback on the implementation side of it and more buy-in into the production side of it. So here you can see the steps in the process. We're going to start with step 1, observe the item menu preparation process. This is where we're literally going to watch the staff produce it. We're going to see how they do it, what what products they use, what tools they use, how things are measured. Uh, all of these things are factored in, which leads us into step two, consider preparation details. Again, this is the how and the why of things are done. We want to look at the productivity of that individual. Are they being productive, or are they losing a lot of steps in the process? Are they using the right tools? If not, then the new tools need to be ordered and taken into consideration. Step three is we write a recipe draft. Now, this is going to be an ongoing process, and it's really important that you use a standardized recipe form. One has actually been supplied for you guys in the supplementals for this particular chapter, and you can keep it and use it however you like. It's really, really important that you use this kind of standardized format to keep a consistency across all recipes. Step four, review and revise the recipe draft. You're going to do this on multiple occasions. You want to make sure you look for correct spelling, you look for grammar, you look for, is it easy to read? Is it correct in its calculations? Is it correct in its diction, and all the different parts of that you want to make sure you're looking at. Step five, use the recipe for preparation. Now, oftentimes I will hand the recipe to someone who's never used it before. And that way I can assure that they're using that recipe for preparation and not something else, or not trying to do it from memory. If I do the recipe that I've written, then chances are I'm likely to make an assumption in that process and not necessarily get it correct. Step five, evaluate the process, evaluate the recipe. Did the recipe provide the correct results that you're looking for? If not, you go to step seven, which is consider further revisions. Now, this may be a looped process where you do this several times to get it right. And then finally, once you're satisfied with it, go to step eight, which is implement and consistently use the recipe. This is going to be the standard that even engineers apply to. This is the way they do it. If you're at NASA, this is how you implement a new procedure. You do this over and over and over. You can substitute the word recipe for procedure, and it works for every single mechanical, electrical, scientific, food, anything related to that. This is how things are implemented. What about recipes for new items? Well, this is not much different. There are a few things that are slightly different in here, but for the most part, it's going to be a similar journey, but it's more involved. And the reason why it's more involved is because you're going to have to come up with different ideas. You're going to have to come up with different ways of evaluating. You don't have that baseline bit of information of watching the person make the recipe prior to that in order to come up with this particular amount of information. So as we go through, we're going to find out we have another 8-step process in here. This is going to be getting into some of the bits of it. Step one, collect recipes for menu items. This is where we can look at different places to find recipes, different resources. You can go online. You can go, maybe you've got a recipe that you quote unquote borrowed from another chef. We do that all the time. Tweak something in there, and now it's yours. Numerous recipes for almost any menu item can easily be located. It's not a problem with that. An early evaluation step is to match recipes with the operations concept. For example, a family restaurant featuring comfort food will not necessarily want a recipe using unusual ingredients and preparation methods that might be found in a fine dining restaurant. Comfort food typically refers to familiar items prepared as a customer might do it at home. Think chicken and dumplings. External recipes should be reviewed for potential use. If you're going to use a recipe as is without any alterations, you need to credit the author of that recipe. So this is why we typically will make some alterations to the recipe and make them ours. Step two, develop recipe ranking scale. Assume that several recipes are of interest in the food production team. Which should be selected? As demonstrated in the first step, one more taste test panel can evaluate food items produced by the recipes. What factors should the taste test panel be considering? The answer to these questions should be incorporated into a recipe evaluation form like the one done in Exhibit 2.4, which you can see as we go forward. This is your standardized evaluation form that gives you some information on analysis of how to do this process. You look at serving size, color, texture, taste, aroma, general appearance, ingredients, compatibility with concept, garnish, appropriateness, and any other things that you might look at. And then should this recipe even be considered? So there's a lot of factors that go into that. So continuing with the different steps. Step 3, have a taste test panel evaluate these recipes. Now this is where you're going to get into the evaluation part that I just talked about. This is going to be, hopefully, you should set it with the dining room place or have a blind tasting even. There's lots of different ways that you could do this. Blind tasting of food items ensure that the raters do not know the recipe, ingredients, or preparation method when they sample the items. This could help reduce preconceived opinions that arrive at the panel that arrive when the panel members have knowledge about what they're sampling. Step 4, select recipe. So once you're comfortable with that recipe, you want to select it to be judged as favorable. So once it's judged as favorable, you want to move forward with it. Now you can rank them and put them in different orders of importance. Maybe one is more important to start before the other. But you want to ask yourself some questions first in this process. Do we have the equipment to be able to produce this item? That's always a big thing. I mean, if it requires a buffalo chopper, you may not have a buffalo chopper. Do food production employees have the necessary knowledge and skills, or can they acquire them? Maybe it requires a person that's adept in butchery or meat cutting skills. Would the operation produce the quality and quantity needed at one time, or use a batch cooking method? In batch cooking, items need to be large quantities are produced in small volumes. So if you've got, let's say for instance, you're making a batch of bolognese, you may choose to do this meat sauce in 5-gallon batches as opposed to 100-gallon batches because of your cooking ability. Are there any special serving problems? Does the establishment have the proper serviceware? And can the establishment safely reuse leftovers if applicable? So these are all things that have to be considered in this process. Another consideration or concern relates to the product cost, which will drive the selling price and the customer's perception of the value. While detailed costing may not necessarily be at this point, a general overview is kind of needed in this particular aspect. Imagine that the new item will be an entree of 1 half-baked chicken with a special sauce. Let's say, for instance, portion size or purchase size will be 2.5 pounds of chicken, chilled on ice. Serving size is a half of a whole chicken. So you can look at this as saying 2.5 pounds of chicken by weight divided by 2 servings gives you 1.25 pounds per serving. So we take that 1.25 pounds per serving and we multiply that times the price per pound. That's $2.80, which gives us $3.50. Now that is our cost per serving. And we do this for every single item on that recipe. We have to be able to determine the cost per serving for every single item on that recipe. Then we add them up and that gives us our total recipe cost. We'll do more of this as we go into some of the other chapters, so don't worry about that right now. We will get into that in more detail. Finally, we developed our food safety requirements involved in the standardized operation, and then implement and consistently use the product. Okay, so we're going to do some math. And I know collective groan, everybody's like, ugh. It's not that hard. Trust me, been doing this for a long time. This is real world application here. This is what we're talking about. This is going to help you tremendously as you go forward. These are real world math problems that I'm going to teach you about that you'll be able to take. It applies to a lot of circumstances, not just food. So first thing we're going to do is we're going to talk about adjusting numbers of servings. Now, it's not complicated. Any kind of recipe adjustment is going to have some little tricks to it. I've got a special way of remembering this that I'm going to teach you that'll make it a little bit easier to kind of follow along with. And It'll make it a lot simpler. So here we go. We're going to get into this. All right, ready? So the current recipe yields 40 servings. That's 3 ounces each. But 70 servings are needed. So let's say, for instance, instead of the current recipe has 40 servings on it, but we have a banquet for 70 people. So we need to take that recipe and we need to figure out what the new recipe is. We're going to call this a recipe conversion factor, or RCF for short. Recipe conversion factors are really easy. A factor is just a solid number that you multiply times. So first thing we have to do is we have to take our desired servings. We're going to call that new. And we're going to divide it by our old servings, which they call current. So we're going to take new and we're going to divide it by old. Simple, right? So we're going to see how that works for us. We're going to take our new, divide it by our old. Say, for instance, here we've got new. My handwriting is terrible. Divided by old. Our new servings are 70 divided by our old servings, which are 40, which is going to give us a recipe conversion factor of 1.75. This is a pure number with no anything after it, no cups or anything like that. This is just a pure number. So when we get that, we're going to take our servings. Let's say, for instance, in this case, the lecture tells us that it is 8 ounces of flour, right? 8 ounces of flour. So we're going to take 8 ounces of flour and we're going to multiply it times 1.75. That's going to give us 14 ounces. So now we know that we have to include 14 ounces of flour in the new recipe. We're going to do that for everything in the recipe. That's the biggest part of it. Everything in the recipe now gets multiplied times 1.75. If you got onions in the recipe, you multiply it times 1.75, and so on and so on and so on. It's really the simplest culinary math you can do. It's just new divided by old. Let's look at another example here. Once we get into that, now you can also change and adjust things like adjusting servings. So by adjusting the servings, we're going to look at things like maybe instead of being I don't know, an 8-ounce serving or a 5-ounce serving or a 4-ounce serving, we're going to adjust the ounce of that particular weight, right? So in this particular situation, the current recipe yields 50 and we're going to serve 50, but it's going to be a different size portion. So we're going to do the exact same thing here. We're going to do our new divided by our old. Don't get confused with all this up in there. It's just the same thing as new divided by old, right? Okay, so let's look and see what that's going to look like. We're going to take our desired servings. In this case, we got our number of servings are 50 for both of them. And then we're going to multiply that times the serving size. Now, what is our new serving size? Our new serving size is 4 ounces. Why? We're making them smaller because, you know, that's the way the world works. Isn't that what happened with ice cream? Yeah, we're going to get with that. Our old serving size was 5 ounces. So that tells us that our new serving is now 200 ounces of product that we're going to use versus 250 ounces worth of product that we did use before. So our recipe conversion factor is 0.80. Now, just like before, we're going to multiply everything in this recipe times our conversion factor. If it's 10 ounces of chopped onions, we're going to multiply that times our conversion factor of 0.8, which is going to give us 8 ounces of onions. We do this for every single item in the recipe, no matter what. If it's water, we do it for that. Really simple, really easy, new divided by old. I can't emphasize that enough. If you remember anything, remember this, and it will be of huge benefit for you. All right, so let's take a look at the next thing. So one more application of this, we can do the exact same thing now if we want to change both of them. So changing both of them is just as easy as changing one, right? This is no different. Absolutely no different. We're going to take our new and we're going to divide it by our old. So let's look at this. Our new one is going to start off with the desired number of servings and desired number of serving size. New, that's our new, right? That's desired. That's how much we want. That's how much we're going toward. So in this case, we've got our 80 desired servings. Our servings are 80. So we've got 80 servings. We're going to multiply that times our new serving size of 3/4 of a cup. You can use 0.75 if it makes it easier, and it truly will make it easier. So a lot of times instead of that, I'll put 0.75. I'll just turn it into a decimal number. And then our old is 60 servings times a half cup or 0.5, which is going to give us our, let's do a little math, 80 times 0.75 divided by 60 times 0.5 is going to give us 60 cups divided by 30 cups for a recipe conversion factor of 2. So now we multiply everything in that recipe times 2. See, here we've got 3 ounces of flour times 2, 6 ounces of flour. Easy. The reason why we do this, the whole point of doing recipe conversion factors is, one, so we don't mess up the recipe and add too little of something or too much of something. But two, we need to know how much to order. Now this applies whether you're doing food or whether you're making a Ford electric vehicle. You have to be able to convert to the amount that you're going to produce. So this works for any instance whenever you're producing something. So take a look at this one. This is for adjusting the number of servings and serving sizes. In this case, we're going to do the same thing. We're going to take our desired servings times our serving size divided by our current servings times our serving size. So in this case, we have 80 servings times 3/4 of a cup, which is going to give us 60 cups. Divide that by 60 servings, which is our old, times a half cup. That's going to give us 30 cups, which gives us a recipe conversion factor of 2. We multiply that times the current recipe amounts, 3 ounces of flour times 2, gives us 6 ounces of flour for the converted recipe. So hopefully this is something that's familiar to everyone. In the United States, we use the U.S. measurements of weights. It's called the imperial system many times. We tried to go to the metric system years ago, but we're stubborn. We're Americans. We do what we want. So it didn't always work. We kind of use the metric system. We use a 2 liter of soda. So here you'll see the common U.S. measurements and weights. One of the things about this is I need to point out the difference between a measurement and a weight. A measurement is a liquid measurement. We're talking about liquid measurements such as quarts, pints, cups, tablespoons, teaspoons. When we talk about weights, we're talking about ounces and pounds predominantly. So let's look at this. 1 gallon equals 4 quarts. That's 128 fluid ounces. 128 fluid ounces is what we call a keystone piece of information. That is a really good piece of information to memorize. When you do that, then you've got all these little keystones are going to be able to help you convert. Makes it a lot easier to keep track of as opposed to having to worry about it multiple times. Now, this is going to be really important stuff because we use this all the time. First off, this is a great chart. Yes, okay, excellent. But let me show you an easier way of getting to that. So what I do is I take, first off, I'm going to look at weights. Because they're easy, not that many of them. What do we have in weights? We have ounces and we have pounds. How many ounces are in a pound? Well, this is pretty easy. There's 16 ounces that make up 1 pound. So if that's the case, a ounce is 1/16 of a pound. What does measures refer to? Measures refer to liquid measurement. Weights refer to the weight of something usually dry, such as flour or rice or butter. Liquid measurements or measurements require you to have something that's liquid. Now, yes, you can measure flour, you can measure butter, but it's slightly different aspects and slightly different calculations in that. So let's look at that. First thing, the smallest unit of measure that we're going to deal with, there are some other things in there, but we're going to deal with teaspoons. Then we go to tablespoons. Then we go to fluid ounces. Don't mistake fluid ounces for ounces. We'll talk more about that in a minute. Then we can go from fluid ounces, we can go to, let's see, cups, pints, quarts, gallons. There are some more stuff this way and some more stuff this way, but we're really not going to concern ourselves about that. We don't really need that for now. Okay, so let's start off easy. How many teaspoons are in a tablespoon? There are 3 teaspoons in every tablespoon. How many tablespoons are in a fluid ounce? There are 2 tablespoons in every fluid ounce. How many fluid ounces are in a cup? It takes us 8 fluid ounces to make up 1 cup. Now, how many cups make up a pint? 2 to make up a pint, or 4 to make up a quart. And then how many quarts are in a gallon? There's 4 quarts to a gallon. So this is my easy way of remembering it. So I look at it and I say there's 3 teaspoons in a tablespoon, 2 tablespoons in a fluid ounce, 8 fluid ounces in a cup. A pint has 2 cups, a quart has 4 cups, and there are 4 quarts in every gallon. So if I did the math right, and I'm pretty sure I did, I can say if I want to know how many fluid ounces, and I don't remember right off my head, I can say 4 times 4, this one up here, times 8, which gives me 128 fluid ounces in a gallon. It's that simple. So now I've already determined how many are in each one of them. I've determined how many fluid ounces are in a gallon. You know, you can literally just work your way backward. And a lot of times I'll, on a test or on a, even if I'm working a recipe or something like that, sometimes I'll write this down just as a reminder to myself. I can do very quick math if I need to. It's just snap, 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 and it's done. And it's a good way to be able to work backward instead of having to constantly remember it. Now, fortunately, we have the capability of determining anything, anytime, anywhere. Hey Siri, how many fluid ounces are in a gallon?
1 gallon is 128 fluid ounces.
Thank you, Siri. Of course, she's not listening to me anymore, but now you see, easy peasy. We don't even need math anymore, right? Don't even get me started on that. But that is how you do common units of measure. Okay, so going back to this chart, we see some common conversions that you might see. 2 pints, 1 quart equals 2 pints equals 32 fluid ounces. So 1 quart is 32 fluid ounces. If you multiply that times 4, you got 128. 1 pint equals 16 fluid ounces. By the way, there's a term we like to call a pint is a pound the world around. That's a old term or an old phrase that we used to use. A pint is a pound the world around. And what that means is that a pint of water weighs the same as a pound of water. This only works when the liquid being measured is the same weight or the same what we call specific gravity of water. It has to flow like water. It has to pour like water. If it doesn't, like say for instance honey or molasses, it's heavier than water. So it's going to have a slightly different specific gravity. So a pint of honey is not going to be the same as a pound of honey. So that's something to keep in mind in the future. So looking at this chart, you can get some examples of different ways that you can convert stuff over. Um, you can convert things from metric to um, imperial units of measurement. But again, I would, if you're not familiar with that step, we're not really going to go into that in here. If you're not really familiar with that step, I would refer to using the calculator online of some kind. Like this one, for instance, 5,000 teaspoons is 24 liters. So here's an example of US measurements and metric equivalents. You can see the gallon, 1 gallon is equal to 3.79 liters. This is really handy if you are in Europe and you're trying to figure out how much a liter of petrol is, or as we call it, fuel, gasoline. Um, but typically you're not really going to worry that much about that. But one of the reasons why we like metric units is because it is much more accurate and much more scalable. So a lot of times you'll find recipes that are written in metric, or sometimes you'll find them written in both. You may find it written in imperial, you may find it written in metric, and you may find it written in a mixture of the two. A pound is 454 grams. I've often asked people how much is a ounce, how many grams are in an ounce, and typically, you know, I usually get one or two that can spout it off really quickly. By the way, it's 28.35 if you really need to know. So 1 ounce is 28.35. I know the book says 28 grams, but if you're getting just 28 grams, you're getting shorted somewhere in that mixture. Anyway, so there's different formats for standardized recipes. One of the formats that we can use is going to be this style of format. This is a sample standardized recipe. This is called a simple format. And it has all the particulars that we need for this recipe. In this case, it's going to tell us what the name of the item is, what utensils we need, the yield of the items. That means how many servings that we're going to get. We also need to know what the serving size is of that particular item. The oven temperature, the baking time, the serving size, the serving tools, all of the things that you would think of that you would need so nothing gets left out of the mix. Then we have all the ingredients and their quantities listed with their units of measure, and then the procedure. Now, a recipe is more than just the units of measure and the ingredient list. Those are pretty much a shopping list. The procedure is what makes a recipe a recipe. Not only that, you may have some special instructions down at the bottom. This recipe sounds pretty delicious, to be quite honest with you. Okay, so the next topic is let's talk about costing recipes. We're going to do more of these as the semester goes. This is something that I want you to get comfortable with because really this is a meat and potatoes issue. The book does not do a great job of explaining, so I'm going to try and do a little bit better job of explaining this particular topic. So let's get started. First off, we've got a materials list here. We've got our spaghetti, our margarine, our celery, our onions, and flour, salt, pepper, chicken stock chicken, mushrooms, green peppers, breadcrumbs, sharp cheddar cheese shredded. So it's got an entire list of ingredients. It tells us the amount. That's how much the recipe calls for. It tells us what the purchase unit is. That's how we purchase it. We don't purchase a quart of celery. We purchase a bunch of celery or a stalk of celery. Stalk is usually one stalk. A bunch is a whole head of celery. We look at the cost per unit. This is the PU, or purchase units. We look at the number of purchase units, how many we have to purchase, and then we basically carry that cost out to get the ingredient cost. We add all the ingredient costs together and we get our total cost. Then we divide it by the number of servings and we get our cost per serving. Let's look at it in a real world example. This is part of the spreadsheet that I gave you for menu engineering. This is why this is such an important spreadsheet. I highly recommend downloading the menu engineering spreadsheet and keeping it. You can use this recipe card and you'll have these forever and ever and ever. So let's look at this. We're going to write a recipe really quick. We're going to keep it simple. We're going to call it, first off, what is today's date? It is the 23rd of August. So 8/23/2002. That's when I'm recording this, by the way. We're going to call this simple recipe number 1. Okay, concept. All right, number of portions. We're going to call this 10. Now, this is a spreadsheet. And if you don't know anything about spreadsheets, I want you to know this. The one thing you need to take away from spreadsheets: do not mix numbers and letters on a spreadsheet unless it is a description. Spreadsheets do not calculate properly if you have a number and a letter in the same cell. So because of that, I've basically separated out the units from the numbers. And I'll show you what I mean by that in a minute. Serving size, we're going to call this, now this is a description, so it doesn't really matter. We're going to call this 10 ounces. And our portion selling price, how much we're going to sell this for. Let's say, for instance, we're going to sell it on the menu for $25. Okay. 25. Just type in 25, just type in the number. It'll put the dollar sign out there with it, so don't have to worry about that. All right, now let's get into this. We've got ingredients. What's our first ingredient? Let's say this is going to be a steak entree. We're going to have New York strip. How much does it weigh? 12 ounces. So I'm going to put 12 here. I'm going to go over here and I'm going to put ounces, OZ. Okay. What is my as purchase cost? Now I know that my as purchase cost is by the pound for a New York strip. So I can't put my as purchase cost by the pound on here because it doesn't equal the ounces. If you look on here, my portion carried over, or my unit carried over. If I tried to put the price per pound here, I'm going to get a bad result. So what do I need to do? I need to take my price per pound and divide it by 16. Why 16? Because there are 16 ounces in a pound. So I'm going to hit the equal sign, and I'm going to say my price per pound is $12.50 divided by 16. Okay, take a look at that cell for a second. This is how you do math in an Excel spreadsheet. So you hit equals, and then the first number divided by the second number. Hit enter. There we go. So now you look at this and you see something's wrong, right? So we need to make some assumptions here. In the problems I'm going to give you, I'm going to give you this information, or I'm going to show you where to go get it. I need to know about yield percent. How much of that product I have left over after I have trimmed it down to its usable amount. That's what yield percent is, okay? The New York strip has a yield percent of 65. So that tells me that 65% of that product is usable after I've trimmed away any gristle, any fat, and any of that stuff. It's 65% of the product left over. Once I do that, once I enter that into it, it's going to give me my edible portion cost. This is the cost of the product that has been trimmed down and is ready to be eaten. So that tells me that 51 cents for every ounce of product that I have goes toward paying for this New York strip. So if it's 12 ounces, Here, it multiplies it times 51 cents, and it'll immediately give me my total cost for that New York strip steak of $6.09. That is how much money it costs to produce one strip steak. Okay. Just remember, you have to put a yield percent in here. What if you have, let's say, for instance, salt and pepper, kosher salt, 0.1 of an ounce. Why? Because kosher salt comes in 3-pound boxes, and there's 12 of them in a case. Now, this is where you need to know something about how things are packaged and sold as well. So here we're going to equal sign. We're going to take our cost per case. It's $25 per case. We're going to divide it. Oops. We're going to divide that by, I'm going to hit the right symbol here in a second. We're going to divide that by 12 in a case. And we're going to divide that by 3 pounds in a case. And we're going to divide that by 16 ounces in a pound. Okay, take a look at that formula for a second. Let's see how that looks. I'm going to zoom in for it here. Okay, again, I'm going to take equal sign 25 divided by 12, because there's 12 of them in a case, divided by 3, because each one of them contains 3 pounds, divided by 16. I've got 16 ounces in a pound. My unit is ounces, so I know I'm where I need to be. This is how you would do the math for that. It's very simple. You just divide it until you get it to its smallest unit, which is the unit you're looking for, and you hit enter. So now that tells me that every ounce of product is 4 cents. Every ounce of salt costs me 4 cents. The yield on this, what's the yield on this? I'm not going to throw any away. I'm not trimming my salt. I don't have to cut my salt down. So my yield is 100%. So my AP unit cost is 4 cents. My total cost is, well, it says 0 cents, but remember, this is calculations, and the computer is actually displaying as 0, but it's actually just a little bit less than 0. Does it affect the total cost of the item? Let's look down here and see. Yeah, it did. It actually went up a cent, a penny. And the reason for that is the computer is displaying 2 digits past the decimal place, but in reality, it's holding thousands of digits past the decimal place, which is going to affect your cost. This is why computing this on a computer is so much more accurate than trying to do it by hand. Okay, black pepper. Let's do the same thing with black pepper. And we're going to call that 0.05 of an ounce. Black pepper costs us, we buy it in a 1 pound ground black pepper for $45. That may sound like a lot, but pepper is expensive. Divided by 16 ounces in a pound. This amount is very easy. We hit enter. $2.81 per ounce of black pepper. That's a lot, but let's see how much it looks. 100% of all the black peppers used. So we use 14 cents of black pepper. May not sound like a lot, but to an overall recipe, it does change things. Pepper is more expensive than salt in general. What else do we use on New York strip? Well, we might use butter. We use, let's say, by the way, I don't know if you noticed this or not. This ounce, it should be actually fluid ounce. Same with this one. Because it's a volume, not a weight. Now, these numbers are not accurate, by the way. I would never use 0.1 of a fluid ounce of kosher salt. I would never use 0.05 fluid ounce of black pepper. This is just for demonstration purposes only. So on butter, let's say, for instance, I want to use I don't know, let's call it 0.1 of a pound of butter. The abbreviation for pound is LB. There's a whole history about how that came about and actually how it relates to the pound symbol, or as you young folks talk about it, the hashtag, and how that was developed over time. Butter is fairly expensive. Butter is going to cost me about $5 per pound. Okay? So $5, I'm at pounds already. So do I need to do anything? No. If I know that it costs me $5 per pound, how do I know that? I go to the grocery store and it comes in a 1 pound block. It may be 4 sticks in there, but each stick is 1/4 of a pound or 1/4 of a pound. And I don't have to do anything else with it. I know that it's there. I just put the price into it. Now, if I get it by the case, maybe that case price is going to be a little bit different. I've got 32 sticks of butter, 32 pounds of butter in a case. I take the 32-pound price, the price for the case, $150 or whatever it is, divided by 32, and that's going to give me my pound cost. Here I already know it, so I'm just going to hit enter. And then how much of that butter do I use? I don't use the paper, but the paper is not the product. You don't get charged for the paper. You're getting charged for the butter. So it's just the same with eggs. You use 100% of a whole egg. You don't have to take the account of the shell in the process. That is something like the carton the egg comes in, essentially. So in this case, it's 100%. Now, let's assume this is everything in the recipe. Okay, let's look at the final price here. The final cost of this recipe is $6.74. Then my food cost for this item is 2.7%. Does that sound right to you? It doesn't sound right to me either. So something is not right in this process. The cost per portion is 67 cents. That tells me that I have done something wrong in here. Number of portions, 1. There we go. So don't be fooled by the numbers. I made a mistake. I didn't do it on purpose. I actually genuinely made a mistake. And because I saw 2.7%, I knew that was not right. There was no way that this recipe cost 2.7% in food cost. That means for every dollar you receive, you're spending 2.7 cents to make it. It didn't make sense to me. Or dollars. Ha ha. Ha ha. But anyway, I changed the number of portions to 1. And now it makes sense. So I made the mistake on that. Now the food cost looks at 27%. Now my budgeted food cost is somewhere around 30%. So I know I'm actually pretty good with this. I'm happy with that. The cost per portion is $6.74. I divide that into 25, and that's going to give me 27%. And that's how we do a recipe cost card. Okay, so the next thing we're going to talk about is how to do a menu item costing. This is very similar to a recipe costing. You can use the same card even. You don't have to do a different one. You can use the same style of recipe costing. I've got one in here in this menu engineering spreadsheet that's actually a little bit different that I'll show you how to do. But essentially, you're going to do the similar thing. You're going to provide it a cost per serving, and that's how we'll do that. So let's see how that looks. Okay, so here is the menu item cost calculator I've got. Let's call this one we're going to call this a New York strip dinner. Okay. I'm going to give it a picture. I'm going to insert a picture here. Nope, I'm not going to do that. I'm going to insert I'm going to take a picture and I'm going to insert it right in there. Maybe. Now I've got me a picture inserted in there. This is my picture that I would have for it. It's a good picture. I like that picture. So this is what's going on the plate. So what's our primary ingredients? New York strip. Quantity is 1. My cost per unit. Where do I get my cost per unit? Well, it just so happened I did a recipe cost card for that exact same thing right here. My cost per portion is $6.74. I'm just going to take that number and put it in here. $6.74. Boom, look at that. Ooh, hey, look, my cost distribution. That's all of that stuff, right? That's my primary ingredient. What's my secondary ingredients? We're going to call this loaded baked potato. BOT. Potato. There we go. Quantity is going to be 1. My cost is going to be, I'm going to have a separate sheet for that. I want to have a separate costing sheet for every item on my menu, not just the plates, but the individual items. If I've got a salad, I want a costing sheet for that. If I've got a cheesecake, I want a costing sheet for that. I want a costing sheet for everything. This is going to make doing these kinds of things, plated costings, very easy. So I did a costing sheet, blah, 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 and I found out that my cost per unit on this is $1.50. Okay, $1.50 in potato. I look and I've got a side salad. One of those, my cost of that is $1.50. And then dressing. What kind of dressing? Ranch. Don't get it twisted. We're gonna eat ranch. I like me some ranch. Quantity of that is going to be 1. And you know what? Maybe they want 2. We're gonna give them that. Cost per unit. Now this is still the cost per individual unit. You don't multiply it times 2. Let the computer do the math for you. So the cost per unit, I look at my recipe card for ranch, and it is 25 cents per each. That's going to tell me that I've got a total cost of 50 cents in there for that. What else goes on the steak? You got that. Maybe you got something in there, some utility and prep costs associated with it. Maybe there's paper products that you use for portioning. Maybe it's any number of things that you might not think of. I mean, there's a lot of different stuff that can go in there. Let's say, for instance, the baked potato was wrapped in aluminum foil. So we'll call it aluminum foil. We used a total of 10 cents of aluminum foil. Okay. Did it affect our distribution that much? No, not really, but you can see it up there. Okay. So that tells me that my total cost here is $10.34. I need to give it an estimated selling price. I want to sell this item for $30. At $30, I'm making 19.66% net profit. We call that net profit contribution margin. If you remember back from the first, from the menu engineering lecture, we call that contribution margin. That means that 34% is my cost margin. That's my food cost. So every dollar of money that I receive, I'm paying out 34 cents to produce this item. Now, I said my food cost goal was 30. Is this out of line? No, because this is a steak. This is one of those plow horse items on the menu engineering, which is going to typically have a higher food cost associated with it. This is why you sell the cheesecakes and the desserts and the appetizers with low food cost to offset this, to help it balance out as an aggregate 30%. So that's how you do a plate costing. It's fairly simple. You just have to do your recipe costings first. And I create a whole book of those when I do that. Completing recipe development requirements. So let's talk about some of the additional requirements that are needed for a standardized recipe. One of them is develop food safety requirements. One of the biggest things that we with is food and food safety. We have to make sure that the food that we produce is going to be healthy, it's going to be good quality, it's not going to make someone sick. So that's really the biggest thing. We're going to use a coaching process of encouraging employees to follow work practices that they've been taught. It's really, really difficult, especially if you're a chef that's there during the morning and not necessarily there at night, or vice versa, that you control your staff. You have to make sure they're washing their hands properly, that they're doing using gloves properly, and whatever your particular organization has. So in this case, we often write what's called a hazard analysis critical control points, or HACCP system. A HACCP system is designed to basically find any possible place where you can make a mistake and eliminate that mistake. So if you think about it, it's not really that complicated. It tells you right in the title of what it is, what it's doing. It's a hazard analysis of critical control points. Critical control points are any place where something can go wrong. So there's 7 principles of HACCP. 1, conduct a hazard analysis, right in the title. Determine the critical control points, right in the title. Now, once we determine these, we want to estimate critical limits. Critical limits are the upper and lower parts of the what is acceptable. Then we establish monitoring procedures. We identify corrective actions. We verify that the system works, and then we establish procedures for record keeping and documentation. Now, I'll tell you this because you need to understand that there's a lot of to do about HACCP in the workplace. HACCP is not necessarily of benefit to us as a restaurant. It may be more benefit to a food production company than it is to a restaurant. In the restaurant, we typically employ something called active managerial control, which is things like check sheets and line checks, temperature logs, and things like that. Whereas HACCP is a much more formalized plan that usually requires quite a bit of research in order to implement it. So one of the things that we can utilize, though, is we can utilize technology. Technology helps us to do quite a few things in standardized recipes. Computer generated recipes, this is what we use a lot of these days. And as a matter of fact, the computerized or the spreadsheet that I've given you is going to be helpful in that, because there are some formulas built into it that you won't be able to change that will make some of the calculations for you. So for instance, we can calculate things like the number of servings needed in a day minus the number of servings available at the end of the shift gives us the number of servings that we need to produce at the end of the day. This is what we do a lot of times with steak counts. Well, at the end of the day, we'll count the number of steaks that we have left over. We know how much we need, and then we will take that number and subtract out the ones we have left over from it. We need 20 steaks for Friday. We have 5 left over from the night before. That means we produce 15 steaks the next morning. It's pretty easy to be able to utilize that. Computerized costing. This is going to be a recipe management software. There's a bunch of them out there now that you can download for free. There's even a bunch of them that you pay big bucks for, depending on your kind of operation. It'll help you generate an ingredient file, a standardized recipe file, and various other applications within it, as well as menu item files. Point of sale system is going to be a big benefit for this, because your point of sale system, if you can plug all that information into your POS system, then now all of a sudden you have a perpetual inventory system that's going to help you keep track of your food costs, which is really, really good to have. I know this is a lot of information, this chapter. We're going to walk through it step by step, so don't be too intimidated by it. We're going to have some exercises this chapter that's going to help us learn some of this material. If you have any questions, feel free to email me or call me. Otherwise, I will see you on the next one.